Have you ever thought that looking at the starry sky is like looking at a time machine? That's right, the distant stars and galaxies we see today are actually from hundreds, thousands, millions, or even billions of years ago. But it's not just that. By observing certain stars, we can also understand how our own sun's life was in the past and how it will be in the future. Hello, everyone. Welcome to our channel, people. Today, I would like to present an example of what we just discussed. So, let's start our video. Music. In a simplified way, we can say that the fate of a star is determined by its mass, or more precisely, by the amount of material placed in its nuclear furnace during the early stages of star formation. For example, low-mass, faint red dwarf stars can theoretically continue to shine for trillions of years. Many red dwarfs are probably as old as our Milky Way galaxy, but none of the ancient red dwarfs have been found yet. This is simply because the universe has not reached the age at which red dwarfs begin to age. On the opposite end of the spectrum are massive and bright blue stars and white giants, with masses equivalent to 10 to 15 times that of the Sun. These stars burn out in just a few million years and end their relatively short lives with supernova explosions. After such an explosion, all that remains is the core of a neutron star or a black hole. But what about stars that are in the middle of their lives, like our Sun? They are said to have a lifespan of about 10 billion years. As these stars age, they start to expand due to a certain thermonuclear reaction, becoming a star called a red giant. Eventually, the substances within the star are depleted, leading to a decrease in its density. In the end, the star's outer atmosphere is swept away because it can no longer maintain its gravity, starting a vicious cycle. When a star expands too much, it can no longer maintain its shape, and its outer layers begin to disappear. This causes the star to lose mass and reduce its gravity, resulting in more matter being expelled into space, and the star losing even more mass. In the end, all that remains is the core of the star, known as a white dwarf. But how do we know all this, considering that the life of a star is short and it's not possible to witness its entire beginning and end? Well, there's a reason why we call the starry sky a time machine. By looking at the starry sky, we can find many stars of different types and ages. This means that it's possible to build a model of how stars of different ages behave. However, red dwarf and yellow-orange stars are much more common than white giants, and stars in their final stages of life are even rarer. That's why all these stars are highly valuable to scientists. The end of the line for giant stars, such as CW Leonis, also known as IRC plus 10216, was one of the few stars that served as a successful comparison and capture of the Sun's death moment. As the name suggests, this star is located 650 light-years away from Earth in the direction of the constellation Leo. IRC plus 10216 is already very faint due to having lost most of its material, and it was only discovered in 1969. This star is in a stage called a carbon star, which is the final stage of a red giant star. In this phase, a certain process occurs in the atmosphere that leads to the accumulation of carbon. Experts estimate that IRC plus 10216 has at most 10 to 30,000 years left. During this period, all the material will dissipate, except for its core. The star's outer layer forms a planetary nebula that eventually cools and diffuses into space. To give you an idea of how much weight CW Leonis has lost, let's present some simple numbers. 1 billion years ago, when the star entered its final stage, it was at least 3 times more massive than the current Sun. Currently, the star's mass is estimated to be 0.7 to 0.9 times that of the Sun. So, the star has lost at least 1/3 of its mass, which is approximately 70% of its matter that has already dissipated into space. Additionally, IRC plus 10216 is a massive star with a radius equivalent to 500 times that of the Sun. It has very strong winds, causing matter to be released from the star into space as a flow. The radius of the stellar wind bubble reaches 84,000 astronomical units. There are several theories about the limit of the heliosphere, but in none of the cases has the radius exceeded 250 astronomical units. This means that the heliosphere has a size 336 times larger than CW Leonis. CW Leonis loses 400 tons of material every day. It's hard to imagine the loss of such a large volume in just 23 years. There's also another interesting fact. This star could be called an oceanic planet. Some years ago, traces of water vapor at nearly 1,000 degrees Celsius were found in the star's atmosphere. It's challenging to determine the source of this water vapor. It's possible that this star had several oceanic planets that ended up burning due to its growth, or it could be the result of some unknown chemical reaction. When will this happen to the Sun? When you look at CW Leonis, it feels like you're looking at the future sound. But when exactly will the Sun become like CW Leonis? Will there be differences between the fate of the Sun and IRC plus 10216? At the end of this video, we will address this question. The current Sun is a middle-aged star, approximately 4.5 billion years old. It will begin to become a red giant in about 5.5 billion years. Certainly, if you can't escape from Earth, you won't be able to witness this. The Sun's brightness will continue to increase, and after 1 billion years, there will be no more life on Earth. Earth will become a planet similar to Venus. However, unlike Venus, the clouds in the atmosphere will not be sulfuric acid clouds, but water vapor clouds from the oceans. This state will last for a few more billion years, and eventually, the Sun will enter the red giant phase. As a red giant, the Sun will start to expand uncontrollably and become increasingly brighter. The brightness will reach its maximum when the Sun is a little over 12 billion years old, and the surface of the Earth will become a sea of lava. The Sun will engulf Mercury, Venus, and it may even engulf Earth. Finally, the Sun will end up as a white dwarf like CW Leonis that we know today. The Sun will expand, lose matter, and become a gigantic planetary nebula that will float through space. In the end, only the white dwarfs will remain. Distant planets may end up moving away from the solar system. This happens because the Sun's gravitational attraction will become so weak that it can no longer hold the planets. The planet may become an interstellar planet in space or remain in its place. We have reached the end of another video on our channel. Thank you very much for watching until the end. I hope you enjoyed the content. Maybe when this cataclysm ends, our descendants will want to travel in spaceships to their homeland, where our solar system used to be. But perhaps the only illumination to guide the spaceship will be the Sun, a pale bright spot in the sky. Don't forget to subscribe to the channel and like the video. Also, share this video on your social networks. It's time for us to say goodbye to our channel until our next content. A big hug and see you next time. Bye-bye.